convolution operation is basically mathematically defined as this, right? And it's a way of adding values locally around a certain interest point, and not just adding it with a certain amount of weight attached to it, each of the values, right? So imagine if you look at this A, B, C, D, E, F, G, H, I, imagine this is your image, right? So imagine these are just values in your image, okay? What you have here is what we call a kernel, right? So the kernel is what you convolve the image with, right? So what this kernel does is you multiply this element with this element, and you add it to the multiplication of this element with this element, and then this element with this element. You multiply and add like that, and what you do is and then your output image will be just the sum of those multiplications and additions, right? So let me actually do a simple example here, right? It's very difficult to do without a board, but let's say this is my image, right? And you have a set of values 2, 3, 4, 7, 2, 1, 5, 3, 6, and then I'm doing convolution with what we call a kernel, right? A kernel is another matrix, right, which provides certain properties to the image when you carry out this convolution, right? So for example, if you convolve with this matrix, right, it's called the identity kernel, you will get the same image out. But if you convolve it with this matrix, you'll just get the edges of the image, right? If you convolve it with this matrix, you kind of sharpen the image, right? So I'll first explain what convolution is, and then kind of give you an intuitive understanding of why when you multiply it with these particular kernels, you get these particular outputs from it, right? So imagine you had this kernel 1, 0, 1, 0, 1, 0, 1, 0, 1, right? Your output image will be a new grid, right, which is going to be the multiplication and addition of all these values, right? So first I'll multiply this into this, that will give me 2. I multiply 0 into 3, I'll get 0. 4 into 1, I'll get 4. 0 here, 2 here, 0 here, 5 here, 0 here, 6 here, right? That's the result of the multiplication, and your final result will be the sum of all these values. So if I add these all up, 2 plus 4 is 6, 6 plus 2 is 8, 8 plus 6 is 14, 14 plus 5 is 19, right? This entire process is what we call convolution, right? So you multiply each of these, right, and then add them all up, and you get one value, right? So what we've really done is we've taken into account all these values, right, and we've weighted it with with this thing called the kernel, right? So if you look at this page, you get these different kernels, right? And what you can do when you have some free time is take a grid of values and see what happens to those values when you multiply it with these different kernels. You can see that something like this will end up highlighting the edges of your pixels, right? Something like this will sharpen it. Something like this will blur it, right? So for example, let's take the blurring one. That's the easiest to understand, right? So you have 1, 1, 1, a whole bunch of ones, right? So if you just multiply by 1, what you're going to get is basically you're summing up all the pixels around a particular pixel, right, by just the value 1, and then you're dividing by 9. So what you're doing is you're saying, so for example, let's go back to this example. Imagine all of these were ones, right? What you're doing is your central pixel of your output image, you're saying is just a sum of all of this, right? And divided by 9. So you're really averaging out all the pixels around your central pixel, and you're putting that as your central pixel, as your output. So what's going to happen then is the image is going to get blurred, because you're just kind of taking all the values around a pixel, averaging them out, summing them up, and then averaging it out and putting it in the center, right? And imagine you do this to every single pixel, right? You move this kernel from pixel to pixel, right? So what's going to happen then is each pixel is just going to be a representation of the average values of the pixels around it, right? So what's going to happen is it's going to get kind of blurred. Does that make sense?
Yeah.
Okay, so that's how you can understand blurring. A similar explanation can be done for edge detection, sharpening, and so on, right? But since we don't have time, I'll let you guys kind of get a feel for it. But the idea here is you take this kernel, you do this convolution operation to the whole image, right? Not just so this, an image is not just usually 3 by 3, right? It'll be a larger image, right? So what you do is you take this kernel and you slide it along each of the pixels in the image, and you look at the values around, and you kind of do a weighted average, and by taking into account the kind of local pixel values around a particular pixel, right? And depending on how you weight that average, so if you take a equal weightage, which is what's happening here, you'll get a blurred image. But if you do something like this, you'll get a edge image, and so on, right? So that's how you can get edge detection, blurring, sharpening, and things like that, right? And if any of you guys like use Instagram or something like that, and you play around with kind of editing your photos, this is kind of what you're doing underneath. Okay, so let's see how we can do this in MATLAB very easily, right? So I'm going to close all this stuff from the previous question. Right, so yeah, I haven't given you guys what do you call it, starter code for this, but we'll need the code that you wrote before, because we are going to do this convolution on grayscale images, because it makes it a little bit more easier than taking a 3-channel image and trying to do this, right? So what I'm going to do is first question 1 in this. Hold on, let me delete all this stuff. If I go to question 1, it says sharpen the Sydney Harbour Bridge image, right? So what you have to do is, we've already loaded the Sydney Harbour Bridge image here, right? And we've converted it into grayscale. That's what we did in the previous section. IM read and then convert to grayscale, right? And then what they've said is use this grayscale image and sharpen it. So if we want to sharpen it, what's the kernel that we have to use? We have to use this, right? So I'm going to say kernel, right? And I'm going to define the kernel. So the kernel I'm going to define is 0, -1, 0, -1, 5, -1, 0, -1, 0, right? So 0, -1, 0, 0, 5, 0. Hold on. It's not 0, 5, 0. It's -1, 5, -1, and then 0, -1, 0. Right? So all I've done is I've just defined that kernel from that wiki page here, right? So for example, if I write this out, I have this. Cool. So now what I need to do is I need to do a convolution between the grayscale image and this, right? So I'm going to say result, or your output is going to be equal to conv2, which is the function. So when you say help conv2, you get how to use it. So all you have to do is put your image and then put the kernel. So if I say grayscale kernel, so that's a small problem that arises when you do convolution, right? Since you're, like in my example, since you're taking a grid of values, right? I'll have values here, I'll have values here. When I do the convolution, right, my output image is only going to have a value here, right? That's what the output of convolution looks like, right? So we are actually losing out on all of this, right? But that's not a problem because you're sliding the convolution, your kernel along every single pixel. So you're doing this to every single pixel, right? By taking into account the pixels around it. But the edges of your image are going to be an issue, right? Because you can't slide the kernel like basically like this onto the image, right? So that can sometimes reduce the size of your image by a set of pixels, depending on the size of your kernel, right? But you don't really have to worry too much about it. There are ways of dealing with it. One way of dealing with it is called padding, right? Again, this is like out of the scope of your tutorial and things like that. But your MATLAB function kind of does all those things for you. So for example, here you can, as a third argument to the conv2 function, you can mention whether you want a similar size image or the reduced size image, right? So I'm going to say same, which means I'm going to get an output that's the same size as my input image, right? So how MATLAB makes sure that the image size doesn't become smaller is it implements some sort of padding, right? Now what padding is and all that stuff is a whole other area to think about, but like if you want you can read up about it. But all you need to really know at this point is when I use the same function, it somehow makes sure that the output image is the same size as the input image. So then what I'm going to do is say I am sure, and I'm going to say result. So now what's going to happen is the image is going to sharpen, right? So let's see the output images. Hold on, I didn't put a semicolon. Okay. Right. So you can see here that your image has, your grayscale image has sharpened, right? So it's sharpened quite a bit actually. Hold on. I'm going to use MATLAB's inbuilt function to do this because I think it's doing the equal averaging. Yeah, that's quite sharp. You can try these different kernels and see what sort of effects you get. So the next question, yeah.
Sorry, yeah, actually I'm getting an error using conv2.
Okay.
ND arrays are not supported.
ND arrays are not supported. Have you made sure you converted your output image into uint8?
I will check. Yeah.
Are you doing?
Oh, sorry, it's uint16.
Right. Also, are you doing it on your black and white image or your grayscale image?
Grayscale.
Okay. Does it work now? And then you can just try it for the second question. It says detect the edges, right? So all you have to do then is just change the kernel. That's it, right? it actually tells you to detect the edges in a different image, the Sydney Opera House image, right? So you can load a different image. And then what you can do is change the kernel. Since you want to detect edges, you select one of these kernels. So I'll basically select this, which is so this should do an edge detection. Yeah, so you can see that the final image is just the edges in the image, right? So you can play around with the values of this kernel, right? So if you want to reduce the intensity of the edges or something, you can try that as well. I'm not sure whether that will actually, yeah, so that's too much. What happens if you go the other way, right? It's really up to you to kind of play around with these values and see what kind of output you really want, right? So I suggest, like, when you have some free time, just look at these kernels and kind of understand what it does to a matrix, right? If you multiply like this, is it intensifying the edges? Is it blurring things by kind of averaging the values around it and so on, right? So you can play around with these kernels, and the rest of the question is pretty much the same. It says here, apply a Gaussian blur to the ultrasound PNG image. So it's pretty much the same, just load a different image, change the kernel, and that's it, right? And then run the code again. So that's question number 2. Any questions before we move on to question number 3? Nope. Okay, so we'll move on to question number 3 then. I'll give you guys about 10 minutes to give it a try.